Good evening, everyone. Our presentation today is about our game project, World of Ice. Now, our developer team contains a total of 5 members: Hồ Thành Tiến, Nguyễn Thế Vinh, Tôn Văn Tấn, Lê Hoài Bảo và Cao Ngọc Anh Tuấn. For our presentation, we will cover 4 main content: the overview, game menu, code design, and the conclusion. Now, coming to the overview, Warbridge is a real-time strategy game where where we use the efficiency data structure like linked list and queue power dynamic unit to maintain and deploy the troops. Our project highlight is the game menu where first you will input your player name and it will later be used in the game over section. And for the main menu, you can either or jump straight into the game itself. Now, when you move to the uh, game panels, basically our panels implement the game constant interface from our core package, and they are use the all familiar panel for the UI design. Our panels use a inner button listener class that implement action listener, and to switch panel we basically call the button listener function. Now, when you move to the in-game screen, you will see all the necessary information from the go to the troop status and your castle have. Now for the play panel, uh, this run game function will basically start at the same time when you click that game button. Basically, this will initialize a timer for the game to ensure a smooth animation for the creature and the generation of gold for the player to use. And moving on to the core.
Our game packet core is served as the foundation for key game mechanics, user input, game setting, UI navigation, and entity management. It contains essential files that define the structures and constant use across the game, ensuring a consistent framework for gameplay. There are many influence of it for the game players manage. Game-wide constant for balancing unit tasks and behavior. It handle user interaction via listener and event-driven programming structure important logic for navigation between UI panel and game state. Moving to the first file of core, we have button listener as the implement action listener to handle button interaction, managing UI transition within the game. Next, the structures of button listener contain the game frame will reference the game window panel transition. The shape panel, holding panel, cut panel will manage UI screen, whilst the screenshot will store the button action command. The card layout will control screen navigation logic. Next. Like system, button listener impact on game UI and hand controlling. Facilitating smooth UI transition between menu, ruler, and play panel. Ensure game start rapidly when clicking start and allow player to quit the game with quick command. Next. Moving to the entity constant, the file define static constant related to game unit, tower, and roger time, ensuring standard value across the gameplay. Next. It contains some key attributes like screen setting, evolution system, going quickly, consuming constraint, combat, mechanic, game rule, UI, miscellaneous setting, and impact on the game. Next. Those vast amounts of attribute, it standardized the combat value, ensuring balance gameplay, define unit health, damage, and evolution mechanic. They establish the foundation for game physics, the attack range and rotor time moment. Next. The game constant class will general game while setting such as screen dimension, UI element, and gameplay constraint. Next. As some key attribute of it, the screen setting will define window size, while the evolution system will control unit direction. Next, Go economy will regulate resource flow, a summoning constraint will limit the troop development in the game. The impact of the game are to define the game interface layout and functionality. Relegate Go economy and evolution costs to balance the resistance during the game. It's control troop summoning mechanic via clear limitation.
Okay, so now let's start at the game frame. So this class act like a main window for our game. So this one we use card layout to switch between different screen like login, menu, and rule screen. So making the interface clean and dynamic. Okay, so all the panels like locking panel, menu panel, and rules panel are added to a cards panel, which is a container that manages the switching. And also we made a custom cursor for the game, just a small touch for the game interface. So overall, this class centralize all UI components and manage transition between them. Next one, we have the game key listener. So in this class, it handle all the keyboard input from the players. So for example, player one can pause or resume the game using space, toggle music with G, and deploy different type of unit using number key like 1, 2, 3, 4. And also the key like Z, X, and C allow players to buy or sell turrets depending on their availability in gold. So before deploying anything, the game will check if the player has enough gold for each troop, and the deployment logic also scale with the player evolution level. Okay, so the higher level you are, the more powerful and expensive the unit. So this class is essential for giving players direct control during gameplay. And finally, it's the hitbox. So this class defines how the game objects detect collisions. So each hitbox object hold a position Y, high, and a rectangle which is used to detect collisions between the entities like enemies, bullet, and towers. So these are methods that like check collide to see if two hitboxes intersect and update to the reposition the hitbox when an object moves. So this makes sure our collision system stay accurate during gameplay. So overall, this class help manage all in-game physical interactions like attacks or movement. So now, let's take a look about the creature.
So now the creator class belongs to the game, inherits from the destructible, and managed create to the move and attack. The first is data structure which used access via index to random uh, store animation image for the creator and if it's check our random access operation. Next, and the game specific with time complex E01 to calculate the attribute based on time and evolution level. Multiplication to determine direction -1 plus 1. Next, the projectile Java with the boy object reference, linear movements, collision detection, and type based in um, implement basis kinematic equation and exchange could be optimized with hash map to replay linear array and circular for object pooling, and finally fixed size array to vector mathematical. Next, the mathematical algorithm with time complex O1 to direction and create new boy object not reference. Next, the range extend the creator to add projected based on combat and manage the collection of projectile and handle strength attack mechanic to use the memory random the plastic during method execution. Next, the data structure for projectile and symbol string to and hand for loop and switch array list to maintain current node reference. Next, the tower class extend destructible and represent defensive structure appear tower defense game. The primary is that a component list to dynamic manage turret without define array size and operation is concept array list access pattern use linked list and random access simulation to relay known as specific position the neutral object. Next, the mathematical calculation is calculate helper with for visual representation. First, iterate to determine the helper and final graphic to use static array to direct the index. Next, and the trace Java optimization of extend linked list data fields and algorithm. Next, foundation branch or some scaling. So now is multi-branch session to construct the next. The coordinate will calculate the position and the final is a check system compile target based on index and evaluation by task calculation. Next.
Okay, for the gotcha. Okay, let's look the foundation in our game objects. That is the gotcha van. This struct class is standard by all major elements on the battlefield, whether it's a creature or tower. At its core, entity stores position is a point object for a quick access and manipulation, and a reference to its box for collision detection. We also keep track of the team type and evolution space, a primitive fields for performance and easy access. A key algorithm here is the get enemy ahead method. It takes a player object representing their opponent, retrieves the linked list of their creature and quickly decides. If there are no enemy creature, my target is enemy tower. If there are, my target is the first creature in the list. This approach is both elegant and efficient with direct index access and no unnecessary iteration. All entities are organized with the inheritance. Subclasses like creature or tower extend entity enable polymorphism and clean code reuse. And by using structure lists for entity management elsewhere, updates and queries are streamlined efficiently across the entire game field. Okay, next. Okay, you can see this a highlight. We use the linked list management of in-game objects like add or edit. And next is a load in minimal time for each enable updates and its clean inheritance, efficient polymorphism and specialized class. Okay, next. Okay, move to the player.java. On the player side is the engine controlling all user or AI game state and actions. For managing a player army, we use linked list, creature, and code creatures, which allow us to add, remove, or scan through the units efficiently and as the game state changes. When players want to queue up new creature for battle, we employ the queue creature, also a linked list, quarantine, first in, first out order so troops only deploy fairly. Here's how it works in code. Queue creatures may go and add a new creature to the support queue group. Some creature pulls the next ready creature from the queue and move it into the active creature list. The critical alternate method relies on real-time logic for player side, looking through the creature and turrets, moving, checking for enemy, attacking, launching projectiles, and resolving death. Every game tick. Finally, remove dead creatures, iterate through the creature list, efficiently up any that has died and rewarding the player with gold for it to move unit. This concentrate data structure, linked list, and queues reliability in managing constantly changing roster, ensuring the game always feel fast, fair, and robust. Okay, next slide. Okay, next. Okay, the DSA's highlight is the link list. Here we'll optimal for dynamic unit roster session or direction happen and the queue, and so the first in, first out ceremony crucial for fairness and predictability, and automated our traverse and process actions per game tick with all efficiencies per player. Okay, next.
Okay. So overall, this project involved creating the Age of War game in Java, applying key data structures and algorithms to manage game logic and data efficiently. So building this game strengthened our understanding of how the DSA concept can be used in real life applications. It also improved our coding and problem solving skills by implementing the game mechanics and optimizing performance. So overall, this project was a valuable experience in combining theory with practical development. Okay, so that's all for our presentation. And now we're gonna take a look at the demo.
Okay, now let's look at our game right here. First, when we start the game, we will see two boxes to enter a username for each user. So let's say player 1 and player 2. Okay, now here's the main screen, here's all the rule, and this is the button to start the game. So now let's start the game. Okay, so this is our in-game screen. Here we can see the name of the players, and here we have space to pause the game and choose the music. Okay, so right here you can see the information about the troops. So first one you can see here is sword, this means swordman. Here is archer, shield, and then fisherman. Okay, so this health, damage, range, and button to deploy the troop. So for player 1 is 1, 2, 3, and 4. For player 2 is 7, 8, 9, and 0. Z, X, and C is for the turret. For example, I click Z, is spawn a turret and will attack the enemy. Okay, so now let's, for example, I'll deploy a troop. It will spawn a troop right here and they will go forward to attack the other team tower. So here I deploy a fisherman to defend. Okay, so you can see right here the health of our tower go down, right? So that is the objective of the game. The other team have to destroy the other team tower, and also you can press A to involve, so your troop will be upgraded and have better HP, better damage. So right here, after upgrade, the sword become the iron sword. The archer have another bow. The shield upgrade the shield, and the fisherman change the fish. Uh, that's for the example. Okay, so how to win? A team have to destroy the other tower to win, right? So let's see. Also, there are 3 level to evolve. Okay, this is the final evolve. Okay, so you can see that the HB of the player 2 tower has gone below 0, so the winner is player 1 right here. So you have 2 options for now, to go to the menu and play the game again, or to quit the game. Okay, that's all for the demo. Thank you.
So that's the end of our presentation. I hope you have a good day.